A very good morning you all. Welcome to the video lecturer part 2 on heat transfer. So in this video lecturer we shall see two important questions related to the composite wall of the heat transfer. So first question, determine the temperature distribution in the composite wall using 1D heat elements. Use penalty method. Okay, it is not required. Use the elimination method of handling boundary condition. Given K1 is equal to 25 watt per meter degree centigrade and K2 35, K3 55 and H is nothing but a convective heat transfer coefficient, that is 30 given, and T infinity 90 degree centigrade and A is a unit area, so area is equal to 1 meter square here. Okay, now there are three elements are given, one K1, K2, K3, and there will be 4 nodes, right? 1, 2, 3 and 4 nodes. So if there are 4 nodes, then what is the resultant stiffness matrix order? It is 4 by 4. Okay, so let us find out the element stiffness matrix for a heat conduction first. So 1, 2, 3 heat conductions. As you know that in the previous lecture we have listed out the formulas, that is Ka by L 1 minus 1 minus 1 1. With the help of this formula, find the 3 elemental stiffness matrix, that particular matrix, right? K is equal to Ka by L 1 minus 1 minus 1 1. So substitute these values, K1 and A is equal to 1 and the length is 0.4. Similarly for this element, K2 35 into area 1 divided by length of the element is, this is 0.2, and K3 55, area is 1 and element length is 0.2. So substitute all these values here and get the results of elemental stiffness matrix. Okay, so you can assemble this afterwards. So here this is node number 1 2 1 2 and this is 2 3 2 3 and this is 3 4 3 4. So assemble this, you will get this stiffness matrix, assembled stiffness matrix. Okay, after that find out the stiffness matrix for heat convection also, because in the previous lecturer we have seen the formula, right? So whenever the composite wall is subjected to free end convection at the left hand side, we need to take 1 at this node and 0 at the remaining nodes. So again there are 4 nodes and only convection is taking place at this end, hence take 1 at this point and rest all 0. It simply means that H convection at the free end is, we have the formula AH1000. So before coming to this video lecture, please go through the formula which are listed out in the previous lecture. Okay, so after noting down all those formulas, see this video. Okay, AH1000, area is 1, H is given, it has a 30 and 1000. Then it is 30 0 0. But what about the rest of all the values? This is entirely 0 0 0 0 and again this is also 0 0 0 0. Hence again assemble those elemental stiffness matrix for a convection, you will get this value. Because we have 4 nodes, resulting matrix will be of the order 4 by 4 only. Hence it is 30, rest all the values are 0. Okay, and now in the previous lecture we have also seen that the force matrix whenever the free end convection is given, that is AHT infinity 1 0. Why 1? Because convection is at the left hand side, so it is 1 0. Okay, 1 is the area, H is 30 and temperature, ambient air temperature is 900 degrees centigrade and it is 1, it is 0 actually, it is not 1, 1 0. So now if you multiply this, you will get 27 10 to the power 3 and it is 0. Now assemble conduction matrix, these all, and convection matrix, this one, and you will get this one. And global convection matrix will be, it is 27 10 to the power 3. Only at the first node it is convection and rest all are 0. After assembling, you will get this one. Definitely, right? Only one value, rest all the values are 0. Now equilibrium equation, that is KT is equal to F. But here in addition to conduction there is a convection also, hence HT is equal to F. Okay, conduction matrix into temperature, convection matrix into temperature is equal to force matrix. So we have conduction matrix, convection matrix and force matrix also. Just substitute or just keep the values all these in this format. That's it. Okay. After that, I'd add these two matrices. You know the matrix addition. Okay. It is 50 plus 30. First row, first column in this matrix. First row, first column in this matrix. Addition will be there. So it is 80. Rest all the values are 0. Hence this matrix will not get affected except this value. Right. So all the values are as it is. And temperature. Don't add temperatures. Okay. No, don't write 2T1, 2T2. It is in a multiplication form. Hence only write T1, T2, T3, T4. And equal to force matrix as it is. Now, applying the boundary condition is very, very important here. In earlier cases, whenever the boundary condition is given, we were directly deleting the rows and column with respect to that given condition. For example, if node 3 is fixed, then we are eliminating node 3, that is third row, third column. But here, temperature is given at this point. It means we know the temperature at this point. Hence, then what we have to do is, that is, this value is T4. Remember, this is not T0, it is T4. So now we know T4, but we need to find T1, T2, T3, right? So at in this condition, what we have to do is, you should not eliminate fourth row, fourth column directly. What you have to do is, you have to use this applying boundary condition from the above matrix by the third row we have. See here, we need to modify the previous matrix. We have to modify the previous matrix, previous row you can say, not matrix, previous row. So actually we have to delete this fourth row, fourth column. Before deleting the fourth row, fourth column, you have to modify the previous row, that is third row. Okay, third row. That is 0 into T1, 0, minus 150 into T2, 425 into T3, minus 275 into T4 is equal to, what is the value? 0. Third row is 0, right? Then minus 150 T2 plus 425 T3. Take this 275 T4 that side, because we know the value of temperature. Just put the value 20 and get the result. It is 5500. Now, very important thing, carefully listen. All the values are in the matrix are same except this value. We have modified the force matrix by using the value of T4, that is a boundary condition. Okay. So rest all the values are same. Then question arises, why we need to take only third row? Why not second row or why not first row? The answer is so simple that when whatever the value you take, no matter except fourth, you should not take this fourth row. Why? Because we are deleting fourth row. Even if you modify, if you get some value here, it is of no use, because anyhow we are deleting the fourth row, right? Hence, always you have to see or check first row, second row and third row, which is possible. So here, is it possible by using the first row? Modification is possible. See here, it is 0 into T4. So we are not taking the help of the boundary condition. So you cannot able to use the fourth row. Similarly, is it possible to use second row? Again, it is not possible, because 0 into T4 is again 0. We cannot able to modify the boundary condition with the help of boundary condition. Hence, we have to take this value only, third row. That's why we have modified. Now, the matrix changes to this one. After eliminating the fourth row, fourth column, we will get only 3 rows and 3 columns. With the help of this, by using calci, you can find the values of T1, T2 and T3. So this is the result. I hope it is understood. If you are having any problem, please make a pause of it and see the formula, then come back to the video. Okay. So we'll see next question also in the same video. A composite slab consists of 3 materials with thermal conductivity 20, 30 and 50, and thickness, means this length is given 0.3, 0.15, 0.15, and the outer surface is at 20 degrees centigrade and the inner surface is exposed to the convective heat transfer coefficient 25 and medium at 800 degrees centigrade. So T infinity value is given here. Okay, and determine the temperature distribution within the wall. Okay, similar to the previous question. Okay, so here what you need to do is again conductivity matrix. There are 4 nodes, 4 by 4 stiffness matrix you will get. So Ka by L 1 minus 1 minus 1 1. So you have the K values and area is given. If it is not given, make it as a 1. Okay, 1 meter square or 1 centimeter square, depends on the data he has given. Okay, so K1 A1 is 1 and length is 0.15. So make a correction here. It is not 1.15, it is 0.3. Length is 0.3 here for the first element. And for the second element, K2 is given and L is 0.15. This is right. And for K3, it is 0.15 and K3 is 50. So use the simple substitution and get the value of stiffness matrix for a heat conduction. And similarly, for heat convection also, that is AH1000. Why 1? Because at the left hand side, heat transfer is given, that is convection. Okay, so it is 1 into 25, 0, 0. So all the values are 0, rest all the values are 0. Hence you will get only 25 at the first node and all other values are 0, similar to the previous case. And what about the force matrix? It is AH T infinity 1 0. Area is 1, H is 25, T infinity is given, it is 800, right? So T infinity is 800 degrees centigrade. Multiply this, you will get 20 into 10 to the power 3. Okay, now assemble them and represent it in the form of equilibrium equation, that is KT plus HT is equal to F, because this composite wall is subjected to conduction as well as convection. Okay, so this is about the conduction and this is about the convection and force matrix. So again add the both matrix. Only first node is get affected because 66 plus 25, rest all the values are as it is, right? And 20 to 10 to the power 3. Again see, again we have they have given the T4 value. It is not T0, again it is T4. 20 degrees centigrade is given. So what you need to do, you have to eliminate 4th row 4th column. You have to eliminate the 4th row 4th column. Before that you need to modify the 3rd row, isn't it? You need to modify the 3rd row in the force matrix. What you need to do, again use this 3rd row and make a modification like this. So what you will get is T4 value is given 20 degrees centigrade, hence force matrix is modified as this. Okay, so this is the modification matrix after the use of 3rd row and boundary condition T4. Substitute, you will get this value. Then what you need to do, eliminate 4th row as well as 4th column. So what you will get, you will end up with 3 row and 3 columns, and this is modified. Earlier it was 0, now it is this value 6666.6. So now with the help of calc you can find the T1, T2, T3 value, 3 unknowns, 3 equations. Okay, so by keeping the mode 3 equation 3 unknown, you will get the value T1, T2 and T3 as 305, 119.72 and 58.075 degree centigrade. So this that's it. This is the second question and the very easiest question on the composite wall.